This video demonstrates two methods for simplifying complex fractions. What is a complex fraction? The name sounds slightly frightening. A complex fraction is a fraction with one or more fractions in the numerator or denominator or both. As usual, examples help to illustrate this definition. Here we have a big fraction with the sum of two fractions in the numerator and the difference of two fractions in the denominator. The second example shows a big fraction with a single fraction on top and another single fraction on bottom. This third example is similar to the first, except that some of the fractions are variable expressions instead of constants. We will consider two equivalent methods for simplifying complex fractions. The first method says if we have one fraction over another single fraction, we can simply divide the two fractions. For example, we can view this complex fraction as a fraction division problem. We have x over x minus 3 divided by 4 over 5x minus 15. To divide fractions, we multiply the first fraction by the reciprocal of the second fraction. Now we can multiply the numerators in factored form and multiply the denominators in factored form. And notice that a common factor of x minus 3 can be cancelled. Thus we get the simplified fraction 5x over 4. Let's consider a second example in which we need to do some preliminary work before dividing. In this case, we have a sum in the numerator and a difference in the denominator. The large fraction bar is operating as a symbol of grouping or implied parentheses in this problem. To add the fractions in the numerator, we need a common denominator. And to subtract the fractions on the bottom also requires a common denominator. The numerator simplifies to 5 over 6, and the denominator simplifies to 7 over 12. Now, since division is multiplication by the reciprocal, we get 5/6 times 12 over 7. After simplification, we get 10 over 7. Let's look at a second method for simplifying complex fractions. This method views the complex fraction as one big fraction and multiplies it by a clever version of 1. First, we want to multiply the numerator and denominator of the complex fraction by the least common multiple of all individual denominators in the expression. Then use the distributive law to simplify both the numerator and the denominator, and finally simplify if possible. Let's start by revisiting a previous example. We have a complex fraction with numerator 1/2 plus 1/3 and denominator 5/6 minus 1/4. The least common multiple of 2, 3, 6, and 4 is 12. So we multiply the whole complex fraction by 12 over 12. When I distribute the 12 in the numerator, I get 6 plus 4. And distribution in the denominator yields 10 minus 3. Combining 6 and 4 gives me 10 in the numerator, and subtracting 10 and 3 gives me 7 in the denominator. Notice this is the same final result we got with the original method. Which method is best is a matter of individual preference. Let's simplify the complex fraction with numerator 1 minus x and denominator 1 minus x squared. The least common multiple of all the denominators is x squared, so we multiply the entire complex fraction by x squared over x squared. We distribute the x squared in the numerator and denominator. In the numerator we get x squared minus x squared over x reduces to x. And in the denominator, when we distribute, we get x squared minus x squared over x squared is 1. When we factor the numerator and denominator, we notice that simplification can occur by canceling the common factor of x minus 1. Our simplified rational expression is x over x plus 1. Finally, let's consider 3 examples in which we get to choose which of the 2 methods seems more appropriate. In general, if there are multiple fractions in the numerator and denominator, the second method simplifies the expression in fewer steps. Here we have to either get one fraction in the numerator and denominator so we can divide, or we can multiply the complex fraction by x over x. The second option seems like less work. When we distribute the x on top and on bottom, we get a simplified expression right away. Let's consider another example in which the least common denominator of all the fractions is slightly difficult to find. Now our individual fractions have denominators x, 2, 3, and x. Therefore, the least common denominator is 6x. We multiply the complex fraction by 6x over 6x. When we distribute the 6x on top, we get 12x over x, which reduces to 12, plus 6x squared over 2, which reduces to 3x squared. When we distribute the 6x in the denominator, we get 6x squared over 3, which reduces to 2x squared, minus 18x over x, which reduces to 18. To see if this expression can be reduced further, we factor both polynomials. Once the polynomials are in factored form, we see that no additional simplification can occur. Let's consider one final example. At first glance, it appears this may not be a complex fraction. However, upon closer inspection, notice that we have negative exponents. Recall that negative exponents means reciprocation. In other words, x to the minus 1 power is 1 over x. Notice also that the negative 1 exponent in the numerator applies only to the factor of x and not to the 3. Now the problem is similar to example 5 above. We multiply the complex fraction by x over x. We distribute x on the top and the bottom. Then factor both polynomials and cancel a factor of x plus 1. We get a reduced expression of x plus 3 over x plus 1.